Hi everyone, second day of reInvent. How's everyone doing? Had a great time so far? Awesome, it's good to see. We're glad to be with you today. We're talking about an important topic today, which is you're under a DDoS attack. Are you ready to respond? This session is CDN306. As by way of introductions, my name's Etienne, and I help customers protect their workloads in AWS using AWS WAF, CloudFront, and Shield Advanced. I'm pleased to be presenting this topic with Nitin, my colleague today.
Good afternoon, everyone. I am Nitin Saxena from AWS WAF and Shield team. Our team's charter is to ensure that bots and DDoS do not impact your applications or infrastructure. And thank you for being here today.
Great. We'd expect you to have some understanding of these technologies we're talking about today. AWS WAF, a web application firewall, CloudFront, our content delivery network, and AWS Shield Advanced, our managed DDoS service. Whilst this is a 300-level talk, and if you're new to some of these technologies, we'll make sure that we bring you along with us. So our agenda today is to discuss what a DDoS attack is, what you can do to respond to that attack, and of course then to look at how AWS helps you behind the scenes. And then we'll lastly, at the end, go through some of our best practices that you can employ so that you can avoid a bad day. For a moment, I'd like you to put yourself in the shoes of an SRE or a team member who manages an e-commerce website and API. It's Friday afternoon, you're ready to kick back, it's time for the pool, and as you get ready to relax, operations contact you. And they say, customers cannot access the web service, they can't place orders, and they need to start triage on what the problem is. What are your next steps? And what would your next actions be? Perhaps you have a prepared plan and you have a set agenda when such an event happens. But perhaps you're still evolving your security posture, and as we know, security is always a work in progress, and this sometimes takes a bit of time to mature. So we'll take a journey with our SRE, our hypothetical SRE, and finding out how you can mitigate for this risk. Before we go down this journey, I'd like to just chat about what a distributed denial of service attack impact is to an environment. In its simplest form, a DDoS attack is a volumetric attack. It's a flood of requests or packets against a public endpoint that can overwhelm an application. And often these requests or packets are from many IP sources. The intention of such attack is to take a service offline or to degrade its performance. DDoS attacks commonly target network or transport layer on the OSI stack, but more commonly is moved into layer 7 where HTTP request floods and the sophisticated attacks that bots can do are becoming more common. Our SRE is facing this very challenge where there is a large volume of requests attacking his web service. We're going to walk through what controls to put in place. So an attack would be distributed across multiple IPs, hitting these endpoints, ultimately impacting a valid user's experience of purchasing a product. I'd like to set the scene by providing some data shared from our Shield response team, who help protect AWS and our customers on a daily basis. On average, we see about 2,000 DDoS attacks a day, or roughly 700,000 year to date. Attacks can range from being short-lived, short and sharp and with lots of volume, to prolonged attacks where there are multiple attack vectors, where an attack would not only just be that of sending a lot of requests, but hiding in some things like brute force attacks against logins or against APIs. Last year, proactive monitoring from AWS detected an unusual spike in HTTP2 traffic against CloudFront, peaking at 155 million requests per second. CloudFront automatically mitigated this request flood, and which is now known as HTTP rapid reset type attack vectors. All right, so what does this look like for our SRE's customers? The site can't be reached. In this case, DNS cannot be resolved. There are so many requests that the DNS service is even overwhelmed. And in some cases where a customer is able to resolve the DNS, they are receiving 5xx errors because the backend services are not able to respond fast enough. So typical errors that you would face as an SRE would include a myriad of 5xx errors, perhaps DNS resolution errors, or just increased latency. So let's talk about what we do when we want to start fixing this. Our SRE is up, laptop's out, it's time to work on the problem. Let's assume that our SRE has not had to deal with a DDoS attack before and is scrambling to resolve this problem. This SRE has to figure out that what systems are involved. So it's important to have an idea of what systems you have under the covers and make sure you understand who are those owners. It's important to have both of these pieces of information to quickly resolve problems. So first step to start triaging is get on a conference call or get in a room. It's important to make sure to know who owns the process of recovery and then who communicates with stakeholders outside of the room as well. Because I'm sure there will be business owners and folk that would want to understand the status. So assigning roles and responsibilities around some of these organizational pieces is important. At this point, we also recommend reaching out to AWS support, enterprise support, or your AWS account team. If you work with an AWS partner, reach out to them as well. Make sure that they are able to join that conference call so that we can all work collaboratively together. So this is our SRE's architecture. It's a fairly simple architecture where there's a load balancer and an API gateway. There's some compute and there's some Lambda, and the application's down. An important part to start to build resiliency as you're dealing with this attack is to start turning on some metrics just so that you can see where the points of contention are. It's important to start with something like CloudTrail first. You're going to have to build up a post-incident review at the end, and so tracking what changes have been made to your environment is an important task. So turning on CloudTrail logging is important. Next, our SRE would turn on CloudWatch metrics for both the ALB and the API gateway. We'll dig into a little bit more about those metrics later. We'd want to enable logging on the API gateway and Elastic Load Balancer. This would help give you a before and after picture so that you can build that post-incident review. The next is to build a Route 53 health check. This is a simple health check just to check if your application's up, just that public endpoint. Perhaps you would want to have two, one for the API and one for the website. And you can start to track your availability improvement by just monitoring that. So we have layered in these technologies. So the metrics we would want to start to monitor. Operations teams would need to have access to have this type of data. You can very quickly construct this in a CloudWatch dashboard or just visit the console to get access to this. I just want to call out some key bits here. Particularly with EC2 workloads, there are two approaches here. You would want to have some form of scale capabilities. Whether you're scaling out or scaling up, you'd need to have some playbook for this. If you don't yet have that, scale out might be the faster approach because you would just increase your auto-scaling capabilities of your group max size. But scale up might require a bit of work to have to test with new instance types. So it's maybe not the first thing to do in an incident, but that is an option. All options are at the table when you're dealing with an outage. So we would want to monitor network and CPU utilization on EC2 instances. That would give you an indicator of how busy those instances are. Particularly with API gateway, we'd want to monitor for error counts. Is the API gateway being hammered and above the request rates that it's capable for? And so you would want to make sure that you're monitoring for those errors. Okay, so now for the fun bit. We're going to start mitigating. Our SRE is starting to take some actions. We've understood that there's a high request rate across both API and across their load balancer. Understood that this is just a straight volumetric attack, and it's a request attack, layer 7 request attack. But because DNS is impacted as well, we'd want to fix that first. So first and foremost, we want to add Route 53. Route 53 is a highly available DNS service and is able to absorb a large volume of DNS traffic. So this is the first step. You want your clients to be able to resolve an IP address. The next is to layer in CloudFront. Always be caching. Wherever possible, you want to offload off your origin. Even if it is for a short amount of time, having short cache TTLs, it is more desirable than not having any. You would even want to cache errors for a period of time. By default, CloudFront caches for 5 seconds. You perhaps want to tune this while under attack so that you give the best chance for your backend to recover. You can protect your APIs as well with this approach. And so you can also cache responses if you choose to, if your APIs have cache responses that are cacheable. If they're dynamic in nature, the next set of remediations will help. So CloudFront provides some key benefits out the gate. The first thing that you're doing to protect by putting CloudFront in place is that there's doing protocol and packet inspection before it gets to the load balancers. It only accepts connections on port 80 and port 443. And you can integrate WAF very quickly, straight from the CloudFront dashboard. So if we've protected the front just from a request path, we need to protect the back-end services. Focused on to access the back-end, and so what we would want to make sure is that we restrict the application load balancer to that of CloudFront IP addresses. We have two options. The VPC prefix list, that you can use in VPC. Alternatively, a recently released feature called VPC Origins that allows you to create a new load balancer that is private in a private VPC and have CloudFront communicate with that. And so that you don't have to add additional controls to your load balancers. All right, so let's dig a little bit into CloudFront configurations. So our SREs start to grapple with CloudFront and just wanting to understand it. First time turning it on. So first, try caching as much as possible. We've got some built-in policies that you can use, or you can tailor those policies for shorter TTLs. And so you start caching content. Much similarly, for specific errors, you can define this for 4xx and 5xx errors. You can define how long you want to cache those errors for. You can decide to customize those error responses, but that might not be the first most important thing to do right now. Our next step, depending on the type of DDoS attack that you're facing, is to turn on the native features within CloudFront to start geo-blocking. Blocking countries where you don't necessarily do lines of business with, and it's a quick fix to help just stop blocking and reducing that request volume. You perhaps want to fine-tune this in WAF later, so this might be a temporary action. The next step would be to turn on logging. You want CloudFront to start logging those requests of what it's serving, and that would also start to give you visibility in the CloudFront dashboard about the performance. We'd want to turn on one additional metric in CloudFront, specifically the origin latency CloudWatch metric. This helps give you a sense of what the backend is doing in terms of how healthy it is. Is it timelessly responding back to CloudFront? There are further metrics that you can review, such as the total percentage of requests, the error rates, and parts of the country that, or the world that are making requests against your CloudFront distribution. Now we can enable WAF. Straight from the CloudFront dashboard, you can enable WAF by simply turning on the WAF web ACL straight from the console. This is a few clicks. It doesn't take much time to employ. It adds 4 rule categories off the bat that you can start with. You can turn this on in monitor mode, which means that you put the request in count mode to start. So you don't have to block anything straight away. You can assert these rules and turn it into blocking mode later. We would want to protect with a core rule set, which is pretty much what every website would want to have, which is based off the OWASP publications such as the OWASP Top 10. The IP reputation list and the anonymous IP reputation list are both derived from Amazon Threat Intelligence, that those rule sets can help prevent risk from IPs that are of known bad actors. You can also prevent request access from known VPNs, Tor nodes, anonymizing proxies, and other hosting providers. This is quite a useful way to just put some base level protection straight in. Lastly is to add a basic IP aggregate key rate limit. This allows you to set for a request rate of 300 or whatever your web service is expecting from a legitimate customer, and you can define this as a general rate limit to start with. We're going to add additional rate limits, but this is the first step. We'll turn this into blocking mode and then enable logging. We would want to start to check what is happening down the track. This is important to understand, particularly again for that report at the end. So I'd like to dive a little bit more into our rate-based controls. There's some really neat things you can do with our rate-based controls, and I just want to highlight two use cases in this scenario. For our SRE, he has an API, and so we'd want to protect that endpoint. In this case, we would want to scope this rate-based control for the /API path. We can use an API aggregate key for IP address alone, but you can add in the authorization header as well, which means that you can create very fine-grained control rate limits. In this case, we're evaluating 50 requests per 300 seconds. We typically recommend putting it in block mode rather than the other actions that we do have, which we'll talk about in the next use case. Okay, so this is a further iteration on an anti-DDoS rule that we had just set, which was just a simple IP rate limit. Here we're combining a host header, the URI path, and IP as evaluation criteria for this rate limit. If there's a unique part of any of those values, it's a new key. So it's an important way of being able to set a very low limit for DDoS protections here. So you can combine something like the host header, path, URI, IP. If you really need further fine-grained controls, perhaps you use query strings a lot because you receive a lot of search queries, and you can protect that here as well. And you can set these values at as low as 10 requests for 60 seconds. In the case of a website, not an API endpoint, just straight web content, you may want to consider something called a challenge. And this is a JavaScript challenge, which we give the browser some work to do to prove out that it's a browser. And so that's a very effective control when you're dealing with a DDoS attack. If you have a mixed environment on one host name, then perhaps block is the approach that you want to stick with. We don't want to break those APIs. As you can imagine, this takes a bit of time to evolve, and you change your rules as you go. Think of this model in terms of when you build WAF rules. You implement a control because you have an asserted idea of what you want to block. You want to observe the logs, which we provide for on the dashboard, adjust that rule, and then move to block or challenge actions. We typically want to use this workflow so that you reduce any impact for any kind of bad decisions that might happen, or an assertion of an idea that you would want to block for something. So it's important to observe, adjust, and then promote to block once you've validated that rule. This is part of building a defense in depth. And so we would want to consider not only just rate-based controls, but payload controls. The size of your payloads that you're going to send through to your backend service. You'd want to build in other geo controls around what countries are allowed or disallowed, or specific regions. You can build in multiple rate-based controls. You can have as many as you desire there. Payload inspection is also a key important area where you want to inspect for SQL injection attacks, cross-site scripting, or for known bad LFI or RFI. So as our SRE works through, he jumps into our WAF dashboard and starts to query the logs. Here are two queries that look at the geolocations of where requests are coming from and the terminating rules, the final decision of when a WAF rule was allowed or not. And so it gives a count of how much was allowed, how much was blocked, how much was in count mode, how much was in challenge. And so that helps give a view of what is happening with that traffic pattern. These, again, can be used in CloudWatch dashboards, or you can adapt these for your favorite SIEM. So in our WAF dashboard, we have some pre-made dashboards that you can use at no extra cost. And these dashboards give that same oversight. Our next step would be to look at what metrics we are going to add to our operations dashboard. Because as we've started to mitigate, with the rate-based rules are kicked in, it's started to protect the environment. We start to see that the right challenges and request rates are dropping, and we're blocking a lot of bad traffic. But we want to make sure that our operations team are familiar with our environment, and so we would want to make sure that we have the right metrics on their dashboards. I want to call out some key ones here. The requests through CloudFront and the total error rates are worth alarming on, so that if you have a higher threshold for requests through CloudFront, that you could trigger an alarm that you paged the right folk in, that something may be happening. Of course, your health check status would be important to give visibility to your team, and to look at the WAF metrics as well. So if you're having high block rates, it suggests that there's an ongoing attack. All right. So our SRE is ready to hit the pool, but not just yet. We need to do a little bit of a post-incident review, and so we would want to decide on when or what the criteria is for when an incident is over. Health checks, so typically it's whether a health check is healthy, the application's responding, or CloudWatch metrics that there's an expected load. And so those are key metrics that you would want to look at. We'd investigate logs for any further issues that you may have and amend rules as needed. You'd add alarms in there as well to make sure that those alarms, particularly for CloudWatch request rates and high error rates, so that you know that there's potential activity happening. And lastly, you want to document any changes you've made to your infrastructure and any further mitigations that you may need to plan for in the future as part of a normal cycle. Now, I do recommend there is a session that we have at reInvent this year, ARC 314, which goes a lot more into how you would best respond to such an attack as a post-incident review, and what learnings can be had from doing such. All right, so our SRE is happy, he's by the pool, and orders are flowing. That is at that point. Now, I'm going to hand over to Nitin, who's going to talk a little bit about what AWS does under the covers to help our customers. Okay.
Thanks, Etienne, for sharing the actions you can take for when your web applications are under DDoS attack. Preventing DDoS attack requires a defense in depth strategy. So this is one thing that we will keep talking about today, is defense in depth. Bots and DDoS operators, these days it doesn't take too much to actually launch a DDoS attack. So as long as we have something to protect, they are going to keep coming after us, and good DDoS resilient architectures are built in layers. And at AWS, we are the first line of defense against DDoS. So in this part of the presentation, we're going to talk about what AWS does to prevent DDoS attacks. As everything with security, DDoS prevention is also a shared responsibility. And today we are going to talk about what we do to prevent DDoS attacks. And later in the presentation, we will also discuss your role in preventing DDoS attacks, which is security in the cloud. So before we discuss how we secure the cloud, let's look at how traffic comes into AWS. So on the left side, we see POPs and transit centers. In the middle, we see our services that we call as edge services, that is CloudFront, AWS Global Accelerator, load balancing. These are our edge services. For CloudFront, the traffic ingresses through POPs, which are located in hundreds of cities around the world. And for regional resources, the traffic comes into AWS-owned transit centers. So traffic comes into a transit center or a POP, it is delivered to the edge services, and from edge services, the traffic is delivered to regional where your workloads live. And AWS Shield standard is a set of services that are sitting in line with the traffic here, scrubbing traffic, inspecting traffic, and this forms the first layer of DDoS prevention in our system, and it enables us to be that first line of defense against DDoS attacks. And AWS Shield standard is available to all AWS customers by default. It is always on, always running and inspecting the traffic. And now we are going to go into a little deeper into what are the different components of the service, how does it work and prevents DDoS. So at this very moment, there are DDoS attacks going on. And AWS Shield is sitting within the transit centers and within the POPs, is inspecting that traffic. So what does it do when it looks at traffic coming into the system? First, it identifies top talkers and applies intelligent rate limits. These rate limits are also resource aware in the sense that it looks at the available compute capacity, in available network resources, and applies rate limiting to the top talkers. It also protects from known threats. And just a bit later in the presentation, we will go a little bit more into what known threats are, how do we know what they are, and how do we gather the data. It is also identifying suspicious traffic, for example, traffic coming from suspicious UDP ports. And it is also doing protocol-aware mitigations, and we will talk a little bit more about what the protocol-aware mitigations are. So this is an architectural view of where Shield infrastructure is located. As I said earlier, the infrastructure, the Shield is sitting in line with the traffic as the traffic ingresses into our edge locations and into our regional locations with the transit center. And given that our infrastructure is distributed globally, it actually allows us to take advantage of this distributed nature of the infrastructure to absorb very large DDoS attacks. Its job is to maximize good put and minimize bad traffic for coming into our network, protecting at the transit centers, protecting at the edge services, thereby preventing it from reaching your workloads. A bit deeper look into how Shield protects our POP infrastructure. So I will give you an example. SYN floods are a very common network layer DDoS attack vectors. So in a SYN flood, the attacker is taking advantage of the three-way TCP handshake, where the client will send a SYN, server sends an ACK, and then the client completes the handshake and completes the connection. So in a SYN flood, an attacker compromises this TCP handshake and sends a whole bunch of SYN requests without ever completing the request. So what can happen with that is that on the server side, your ports can get exhausted while you are still waiting for these ACK to complete. So Shield incorporates a SYN proxy sitting at the very far edge of the network, where it directly mitigates SYN floods from forever coming into our network. And it also look at other things like suspicious characteristics, UDP source port, and also there are times when attackers are trying to compromise AWS network by using our services to do a reflection attack somewhere else. And Shield also looks at those and absorbs those attacks sitting right at the edge. At our border network, Shield does everything that we saw at the edge network, but it does a bit more. For our regional and border networks, it is applying the SYN proxy for absorbing the SYN attacks. It is using the top talker and the suspicious traffic but it is also doing resource-aware mitigations and configuration-aware mitigations. So for example, if you have geo-blocking and network ACLs configured, that traffic is filtered right at the edge before it ever hits the region. Other example is when, in some cases, DDoS attackers try to look for vulnerabilities on open ports, and they try to overwhelm the server, sending traffic to a port that the service may not actually be listening. So what Shield does is that it looks at the global accelerator configuration and knows what ports AGA is listening on, and when it sees traffic that is coming into a port that AGA is not listening on, it will disallow the traffic from ever reaching our edge services. So this way, top talkers, protocol-aware mitigations, resource-aware mitigations, Shield is absorbing very large amount of layer 3, layer 4 attacks coming into the network. So far we've been talking about layer 3 and layer 4. One of the questions we often get is that many of the AWS services are multi-tenant, whether they're databases or CloudFront, or most of the applications are multi-tenant. So if one of our customers receives a DDoS attack, will my applications be impacted in any way? And the answer is no, because this is one of the core tenets of Shield, is to isolate attacks, keep our services running smoothly, and what we call noisy neighbor protection. So this is something that it is automatically there, preventing multi-customer impact whenever a particular resource is getting attacked. So let's talk about layer 7 a little bit. Remember when Etienne was giving the example of the SRE and when the SRE was coping with the DDoS attack, they brought in CloudFront to absorb the attack. So why CloudFront is so important in a DDoS resilient architecture? In the past few years, the DDoS attacks have notably shifted from layer 3, layer 4 attacks into layer 7 request floods. And even within layer 7 request floods, there are novel kind of attacks like the HTTP route to rapid reset attack that Etienne also referred to. So layer 7 request floods are very easy to conduct. There are DDoS for hire websites, they pay in crypto, and launch an attack. So and request floods can be difficult to mitigate at the packet level, because they look a lot like normal traffic. So yes, you can look at volumetric things, but you can't look at anything about the request. So we built DDoS detection and mitigation capabilities right into our edge service, which is CloudFront. So just like the HTTP rapid reset attacks, CloudFront does a whole bunch of different things to protect both attacks coming at a network level as well as an IP level. So let's go a little bit deeper into how that works. So just like Shield, CloudFront is also looking at top talkers. It is protecting from known threats, and it is mitigating and absorbing these attacks within 5 to 10 seconds. The difference is that it is looking at both IP and request level. What does that mean? It is doing layer 7 protocol-aware mitigations. HTTP to rapid reset, for example, where CloudFront mitigated that attack on a day 0 and absorbed something like 155 million peak RPS coming into our infrastructure. CloudFront looks at top talkers, but also looks at request entropy. Request entropy means that, let's say you have normal web traffic coming in. The web traffic has a certain signature. There are request headers, there are referrer headers, there are TLS fingerprints associated with it. Now, when DDoS traffic starts to come in, the request attribute for HTTP requests, and since CloudFront is in the layer 7 request path, looking at X forwarded for headers and all other kind of information that's only available at layer 7, it can look at anomalies and variations that you cannot see at the network level, and it uses those anomalies combined with the volumetric changes of traffic behavior to determine whether it's a DDoS, and it performs those mitigations both at a IP packet level as well as at a request level. So this is one example where a few months ago, CloudFront absorbed over 90% of this attack on its own without having any impact down to the application. 3.5 billion requests in about less than 7 minutes, and CloudFront was able to absorb. And there are two lines here. They both show the packets blocked as well as the request blocked. And our mission is to protect our infrastructure, protect your applications, be that first line of defense for DDoS. And we are continuously mitigating a vast volume of very large attacks that are coming into our infrastructure. So let's talk about known threats. So earlier in the presentation, I alluded to both CloudFront and Shield protecting against known threats. So what are known threats? How do we know that they are threats? So over the course of time, our strategy has evolved to create first-party verifiable threat intelligence and use the threat intelligence to mitigate malicious requests from getting into our infrastructure and to your applications. So let's look at basic principles of how threat intelligence gathering works. Threat actors attack targets. When they attack targets, it always leaves behind artifacts. Those artifacts could be IP addresses, those artifacts could be request signatures, malware payloads, but they are always there. So we look at and analyze those artifacts and convert those artifacts into threat intelligence and use the threat intelligence to mitigate future actions or similar actions by different threat actors or the same threat actor. And so how do we do it? How do we create first-party verifiable information? At the core of our threat intelligence gathering apparatus is something we call honeypots, which is a global fleet of EC2 instances that replicate applications that have vulnerabilities. They replicate open proxies, they replicate IoT devices. To an attacker who's scanning the internet for open ports and software, these look no different than your applications. So naturally they come after us. We see billions of interactions per day. When we see those billions of interactions, we are analyzing those request payloads, signatures, whether this IP was seen trying to perform malicious activities across multiple customers. And the purpose of this honeypots infrastructure is to generate the data and enable that data for research. Once we have the data, we convert the data, curate the data by threat indicators such as, is this an IP address that is attacking multiple? Is this an open proxy that's being constantly abused? Is this a command and control infrastructure? Are there malware payloads that are attached to things coming from this particular source of IP addresses or proxies? And then we use the threat artifacts and indicators to generate unified records called threat intelligence. And this threat intelligence is then further used by all these products to mitigate threats at the edge. So all of the services mentioned in this presentation and many more use the first-party threat intelligence gathered by AWS to mitigate malicious activities and threat actors. Our threat intelligence has prevented hundreds of thousands of attacks this year alone. But that's not the least. We also use threat intelligence to disrupt threat actors by providing this information, this actionable intelligence to team within AWS and relevant external parties to take down threat actors, botnets, to disrupt them, to make internet a safer place for all of us. So far we have discussed how we secure the cloud and be that first line of defense. But So I gave you an example that CloudFront absorbed 90% of the attack, which is great news, that 90% of a very large attack was absorbed right at the edge before it ever reached your application. But even the 10% of the attack can come and disrupt the applications. So why is it that we cannot intercept all 100% of the attack? There is a fine line, and the fine line is false positives. We do not know your application. You know your application. So we are making educated guesses about top talkers, rate limits, and trying to distinguish between DDoS events, flash crowds. But the trade-off we have to maintain is that if we go too aggressive in our controls, it will start to impact your actual workloads. If we relax them too far on the other side, it will start to impact the application. So we walk that very fine line, but we provide you additional services that tips on how to create those DDoS resilient architectures so that you can play your role in building a layered defense in-depth strategy that ultimately protects your application. And I'm going to give it back to Etienne to talk more about DDoS resilient architectures. Thank you.
Thank you, Nitin. Thank you, Nitin, for all the hard work your team does to keep our customers safe. All right. So, if there was one QR code that I'd want you to take away today, this is it. I will flash it up again at the end, but this is the one to take. This is our DDoS resiliency guide, which gives a lot of detail around how you can build resilient architectures. This diagram is from there, and we'll talk through some of the high-level topics here. What I want to call out here is when you layer in CloudFront, you're getting access to Shield Standard, which is what Nitin and his team have built. And so Shield Standard is baked into CloudFront, and you get that benefit from the get-go. This is why it's so important to layer it into your architecture. And you can put that in front of your API gateways to protect your API gateways. The next benefit behind using CloudFront is that there's some native cost benefits there as well. There's a free tier there and free SSL certificates. So taking advantage of CloudFront is certainly something worth considering in best practices. If you have a non-HTTP workload, you would substitute CloudFront for that of Global Accelerator. So that's also another one of the services that Nitin spoke about earlier. By layering in this technology this way, you help build a defense in depth. By having WAF on CloudFront, you would be able to apply rate-based controls and block and challenge IP addresses that perhaps are dubious in nature. And so you can mitigate for that at the edge of the network before it gets anywhere near region. You can elect to use Shield Advanced. This is an optional item that you can elect to use. And what this is a service that is a managed DDoS service where there's a response team behind the scenes, a 24/7 team, that you can reach out to if you're having a bad day, and they can help build mitigations and help you build your WAF rules if that's what you need. They'll also give you visibility into the type of attack vectors that they're seeing, and so it's definitely worth considering if DDoS prevention is something that you want to address. But I would also argue that it's a good place to start with the basics in mind. Make sure that you've got WAF and CloudFront in place to start, and then layer in Shield Advanced after that. Of course, when we talk about defense in depth, we talk about Firewall Manager, Security Hub, and Guard Duty as well. I just want to call out Firewall Manager here. When you subscribe to Shield Advanced, you get Firewall Manager as part of the package. The reason for this is that it allows you to scale out your protections. You can subscribe your AWS organization to Shield Advanced. You can drive out WAF policies at scale, set security groups at scale, and your network ACLs at scale. So Firewall Manager is really the piece to help multiply your time, to reduce your time taken to achieve an outcome at scale. Yep. All right. So let's talk a little bit about WAF rules. When we talk about defense in depth of WAF, we've got a number of rules. We've spoken a lot about rate-based controls, but I'd like to talk about others. Rate-based rules are important, and using multiples. IP reputation lists, these are critical, and be able to label requests appropriately so that you can decide what you want to do later on in your rule evaluation. Customer managed rules, these are rules that you can create. These are easy wins that your teams have already identified risk for. So have block lists and use those. We have what I call living rule sets, or these are rule sets that are regularly updated and they are versioned, and you can switch to them and turn them on. These are for the specific workloads that you're using, such as if you've got a Linux backend service or a Windows backend service, there are rule sets that are appropriate for your workload. Lastly, we have our Shield Advanced automatic rule that if you're a Shield Advanced subscriber, it will sit inside your rule sets and it will be automatically updated by Shield Advanced. So when it detects a flood, it would update it for you. Then we have bot control and fraud control. These two rule sets or technology suites are allow you to deal with specific risks that you may be facing. And so if you're dealing with bot activity, we have a bot mitigation solution there. And fraud control is specifically aimed at dealing with brute force login attempts or folk creating lots of accounts in your service, because there's some benefit to be had. So, how would we build these rules? What order? We would build this in a fashion to be as cost effective as possible, layering in bot, IP reputation, use case specific and rate-based controls at the high order. Starting with that rules out a lot of risk already. Before we start to deal with Shield Advanced, which is obviously dealing with volumetric attacks, and then of course bot control and fraud control rules. By doing so, you make it as cost effective as possible. There may be some variance depending on your use case, but this is a good mental model to work with. Okay, so let's cover a little about what your role is as you build applications in AWS. I recommend reviewing your rule sets on a regular basis. You don't want to just have rule sets that sit stagnant. You want to go back to them every so often, whether that's part of a deployment cycle or whether that is part of a compliance cycle where you need to review these things. Use rate-based controls. It's worth adapting and changing these controls as time goes on, and adapting based on the risk that your teams are seeing. Use Route 53 health checks. They are a simple control to just see if there's risk and alarm you if there is something that is out of sorts, if there's an availability issue. The CloudFront and WAF dashboards have a myriad of detail in there. Particularly the WAF dashboards are a great place to start and at default offer a lot of value to start filtering out risk. Consider Shield Advanced if you need that protection. If you use Shield Advanced with those Route 53 health checks, the mitigations kick in with Shield Advanced a lot quicker around rate limiting and protecting your workloads with WAF. All right. Lastly, schedule a well-architected review with your account team. This is certainly something worth doing because it'll help expose if there is any fragility in infrastructure or something that we need to deal with, just so that you have the most available applications. All right, what is a control worth if you haven't tested? It's important to conduct DDoS and pen testing. This makes sure that these controls that we've suggested are in fact doing what they should. So we suggest make sure that you test your controls. Review your incident response processes. This is important, particularly from a viewpoint that applications change over time, and it's important to have the right people in the room when an application is under attack. And lastly, please engage with the SRT team. These teams are there to help review your environment, to help make sure that you have the best outcome in protecting against DDoS attacks. All right, I did mention that we would put up the QR codes a bit later. There are two additional ones that I want to call out. We have our DDoS resiliency best practices, prescriptive guidance for bot control that contains a lot of what we've spoken about, how to build these WAF rules. And for our operations folk who have to deal with the log dives, we've got a bunch of different examples there that you can use to help drive an outcome. All right. Again, thank you for your time. Thank you, Nitin, for coming through to present. Thank you, team.